maintain constant potential difference between the two terminals. Now, okay, so why does battery positive terminal, negative terminal of the battery connected to the connector? Why does battery decharge when positive terminal, negative terminal of the battery connected to the connector? These two questions I'm going to answer. We know very well this is a battery. This is a box. This is a battery. This is a battery. This is a battery. This battery consisting of two electrodes. This is the electrode 1. This is the electrode number 2. So this battery consisting of two electrodes. This is the electrode 1. This is the electrode number 2. At the same time, this battery consisting of chemical. At the same time, this battery consisting of chemical. That's chemical. So finally, the battery consisting of one box and two metals. These two metals are electrodes and chemical. The chemical. We know very well in the conductor, positive charges are moving. Positive charges in a conductor. In conductor. So current is due to positive charges moving. Positive charges moving high potential to low potential. Current flows from high potential to low potential. Negative charges are moving from low potential to high potential. Current flows from high potential to low potential. Current flows in a conductor. In a liquid. So positive ions, negative ions. So positive ions, negative ions due to current. Current is constituted. Here, the chemical having positive ions, negative ions. Positive ions, negative ions. Here, this is a battery. The battery having two electrodes and a chemical. Chemical having positive ions, negative ions. Positive ions are moving one of the plate. Negative ions are moving another plate. How does this ions moving from one plate to the other plate? How does this electron moving? How does electrons are moving from one plate to another plate? This chemical having positive ions, negative ions. Positive ions are moving one plate. This all positive ions accumulated on this plate. This plate becomes positive plate. And negative ions are moving opposite to the positive ions. This negative ions are moving towards this plate. This negative ions will be accumulated on the plate. This plate became a negative plate. This is a anode plate. This is a cathode plate. But positive ions are moving. Positive ions are moving one of the plate. These positive ions will be accumulated on this plate. This plate became a positive plate. Negative ions are moving opposite to the positive ions. These negative ions will be accumulated on this electrode. This plate became a negative plate. This negative plate is called as cathode. This is a positive plate. This plate became a positive plate. This plate is called as anode plate. So why electrons are moving? Why positive ions are moving this plate? Why negative ions are moving this plate? By the chemical force. Chemical force exerts a chemical force is acting on the positive ions. Positive ions are moving this direction, and the chemical force is acting on the negative ions. Negative ions are moving this direction. So this is a positive ions. Positive ions are moving this direction. Negative ions are moving this direction. Now, here one point is this is a Chemical force. The chemical force is depends upon chemicals. Chemical force is depends upon concentration of chemical. Chemical force depends on concentration of the chemical. Concentration of the chemical. Come to the point. Next. Positive ions are moving left side plate, negative ions are moving right side plate, But positive ions are moving this direction, negative ions are moving this direction. Up to this is a positive ions are still positive ions are moving this plate, negative ions are moving this plate, negative ions are moving this plate. Up to the charges are moving. Charges are moving. We have the clear condition. Condition number one, FC. Okay, FC means chemical force. Chemical force. Okay, come to the point. Chemical force. Positive ions are moving this plate. Negative ions are moving this plate. Negative plate. Here, this is our battery. Okay, in this situation, positive ions are in the motion. Negative ions are in the motion. So what force will come to the picture? Electric force. Electric force will come to the picture. Positive ions are moving towards this plate. Negative ions are moving towards this plate. But finally, what is the point? Common point. Positive ions are in the motion. Negative ions are in the motion. We know very well, ions in the motion, one more force will come to the picture. Positive ions in the motion, negative ions in the motion. Okay, common point is, ions are in the motion, one more force will come to the picture. The force is called as the electric force. This electric force depends upon sufficient charges accumulated on the plate. Sufficient charges accumulated on the plate. So what I'm telling, so positive ions in the motion, negative ion in the motion. Common point is, ions are in the motion. One more force will come to the picture. That force is electric force. This electric force depends on concentration of the ions accumulated on the plate. Electric force depends upon sufficient charges accumulated on the plate. That is electric force. Okay, come to the point. We have the condition. We have two forces. One is chemical force. Second one is, this is a chemical force. This is a chemical force. This is an electric force. This is a depends upon concentration of chemical force. This is a depends upon sufficient charges on the plate. Next, we have a condition. FC greater than Fp. Like second situation, Fc is equal to F. In this condition, we have one more condition, that is we don't discuss that one. We are going to discuss these two conditions. First condition, Fc greater than Fp. Fc is equal to Fp. In this condition, what will happen in this condition? Fc greater than Fp means chemical force is greater than to the electric force. Chemical force is greater than to the electric force. What will happen? Still electrons are positive ions are moving towards this plate. Negative ions are moving another plate. Positive ions, negative ions, both are moving in opposite direction in this condition. Next, the second situation, Fc greater than Fc is equal to Fp. In this condition, what will happen in this condition? This is a ion, negative ion. For example, this is a negative ion. This is a positive ion. How many forces we have? Two forces. One is chemical force, other one is electric. For example, chemical force. This is a chemical force. Electric force. This electric force push the positive charge this direction. Next, this is a chemical force. Chemical force push the positive charge this direction, and this is a electric force. Electric force Whose the positive charge is this direction when both forces are equal. What is the net force? What is net force acting on the charge is chemical force minus electric force. Both forces are equal. Chemical force minus chemical force. Net force is zero. The charge is rest position. This is a rest position. The ion is rest position. This positive ion is not moving to this plate. This negative ion is not moving to this plate. When in this condition, Fc is equal to Fp. In this condition, both forces are equal. Net force is net force acting on the ion is zero. The this is a negative charge is rest position. Positive charge also rest position. So what condition? Fc is equal to Fp. In this situation, net force is acting on the ion is zero. That's why the positive ion is not moving. Next, negative ion. Net force is acting on this ion is zero. This negative ion is not moving left side or right side. It is rest position. In this condition, positive ions, negative ions are not moving towards the plate. In this condition, Fc greater than Fe means in this condition. What will happen in this condition? First situation. This is one more battery I am getting. Plate. This is a positive charge. Fc greater than. This is electric force. This is a chemical force. Chemical force is greater than 2. Electric force. This is a positive ion is moving this direction. Fc is greater than Fe. This is Fc. Fc force is acting on the positive ion. Chemical electric force is acting on the ion. But chemical force is greater than 2 electric force. Finally, positive ion is moving this direction. In the first case, positive ions are moving this plate. Negative ions are moving this plate. In this condition, positive ions, negative ions are not moving towards a plate. That's in this condition, the battery maintains constant potential difference between the two terminals in this condition. So when you buy battery from the shop in this condition, positive ions, negative ions are not moving towards a plate. You buy new battery from the shop in this condition. This is a in this condition you are not going. Okay, in this condition. So this is our first one. So why does battery maintain constant potential difference between the plate means? This is the answer. Okay, next. Next. So next question is in this concept. Next question. So why does battery decharge when positive terminal, negative terminal of the battery connect to the conductor? Okay, that is this is a battery. This is a battery. Positive terminal. This is an electrodes. This is electrode is positive charge. This electrode is negative charge. This is a conductor. This is a conductor. This is a this is a conductor. So this conductor, this is a negative terminal. This is a positive terminal of the battery. Positive terminal of the battery is connected to Y. This is a conductor. This is a conductor. This is a conductor. Now we'll see this conductor. I am showing this. The why. I'm showing why. Showing why. This kind. We know very well the conductor having number of free electrons. The conductor having number of free electrons. This is a conductor, open conductor. This is a open conductor. Number of free electrons. This is a conductor, open conductor. This conductor having number of free electrons. Number of free electrons. All electrons are moving in a random direction. This is a conductor. This conductor having number of free electrons. Number of free electrons. Suppose this conductor is connected to this conductor. This is a conductor. One end is connected to positive terminal of the battery. This is another end of the conductor. This is connected to negative terminal of the battery. This conductor is connected to positive terminal of the battery, negative terminal of the battery. Immediately electric field set up from positive terminal of the battery to negative terminal of the battery throughout the length of the wire. So what is the length? Length is L. Length is L. All electrons are moving. All electrons are moving. Lower potential to higher potential. Lower potential to this is higher potential. Low potential. Positive charge gives positive potential. Positive potential, that is high potential. Negative charge gives negative potential, that is a low potential. Electric field is set up from high potential to low potential. Electrons are moving from low potential to higher potential. Current flows from higher to low, higher to low. Due to velocity set up from low to high, low to high. Already I explained that basic one. That is a basic, very important. This is a open circuit. This is a closed circuit. In open circuit, this is not connected to the battery. This wire is connected to the battery. The wire is not connected to the battery. This wire is connected to the battery. This is not connected to the battery. All electrons are moving in a random. All electrons move in random direction. This wire is connected to the battery. All electrons are moving from lower potential to higher potential. Current flows from higher potential to lower potential. Electric field set up from higher potential to lower potential. Due to velocity set up from low to high, low to high, low to high. So come to the point. All electrons are moving. This is a high potential. This is a low potential. Low potential. High potential, low potential. Electrons are moving high potential to low potential. This is electrons moving low potential to high potential. All electrons are moving from low potential to higher potential. Higher potential. This is a positive plate. We call this is an anode. This anode will attract negative charges. Attract negative charges. This is a negative plate. This plate having negative charge. This negative charge will repel to the electrons. This negative plate having negative charge. This negative charge will repel to the negative ions. The arrow mark, this arrow mark indicates electron. The arrow mark indicates electron. Arrow mark indicates electron. What is the charge of electron? Negative. So this is a negative charge. This negative charge will repel to negative charge. This electron is moving this direction. Electrons are moving this direction. At the same time, here this positive plate will attract negative charge here. Positive plate. So this positive plate will attract negative charge. 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 A few negative charges will accumulate around the plate. In this condition, positive plate, strength of the positive plate is decrease. In this condition, FC greater than 0. Before condition is before. So when I am taking a battery, when I am taking a new battery, FC is equal to FC. So when I am taking battery, suppose this is all. I'm not connecting the wire. Suppose in this condition, in this situation, Suppose battery is not connected to conductor, battery is not connected to the wire, Fc is equal to Ft in this situation. This is the first situation. Electrons are moving in a random direction. This is a open wire. This is a open wire. This is a battery. You are taking. This is a battery. Okay. Next, in this situation, this is a Fc is equal to Ft. Fc is equal to F. Suppose, for example, this is a new battery. So we buy new battery from the shop in this condition. In this condition means positive ions are not moving to this plate, negative ions are not moving to this plate. This is a new battery. The new battery maintains constant potential difference. We buy new battery from the shop. The battery maintains a constant potential difference between the two terminals. This is a new battery. Fc is equal to Ft condition. Suppose this is a battery. This is a battery. This is an electrode. This is a electrode. This is a negative plate. This is a positive plate. This is a wire. This is a wire is connected. Here, wire is connected. Circuit is closed. Positive charge gives high potential. Negative charge gives low potential. Electric field is set up from high potential to low potential. Outside is this is a electric field. Direction of electric field. The arrow mark indicates direction of electric field. All electrons are moving. Which direction? All electrons are moving. Low potential to higher potential. This positive charge will attract negative charge here. This positive plate will attract negative. This positive plate will attract negative charge here. This positive plate will attract negative charge here. These negative charges will repel to negative charges downward direction. This negative plate will repel to negative charge. The negative is moving down. This is the positive plate. This positive plate will attract negative charges towards the plate. A few negative charges will accumulate on this plate. This is a new battery, but in this battery is connected to the conductor. What will happen? This sufficient charges, chemical force, electric force depends on sufficient charges on this plate. So sufficient charges decreases. Sufficient charges on plate decrease. Chemical force also decreases. Electric force decreases. Automatically. So what will happen? Electric force decreases. Chemical force increases. Chemical force increases relative to electric force. What will happen in this situation? Chemical force is greater than electric force. Here what will happen? A few negative charges will be stay on the positive plate. Electric force depends on sufficient charges on this plate. Sufficient of the charges on this plate decrease, electric force decreases. Chemical force increases. Electric force decreases. In this situation, chemical force will attract negative charges. This is a chemical force. Name is, this is name is chemical force. This is a chemical force. Chemical force is more than to the electric force. This chemical force will bring the charge, negative charge. This is a bring the negative charge. This person, chemical force, pull the negative charge. This chemical force pull the negative charge towards this place. Towards this place. This is shifting here. This is a negative charge. This is also negative charge. Here, more repulsion force between the two charges. These negative charges will enter into the wire. Will enter into the wire. This is enter into the wire. Next, this chemical force. Next, this chemical force. This chemical force. This chemical force will chemical force. This chemical force push the negative charge. This negative charge put here. This is a negative charge. This is also negative charge. This negative charge will be repel this one. This negative charge will enter here. Enter here. So next, this is a chemical force. Next, this chemical force push this negative charge. This chemical force will put this negative charge put in front of here. This negative charge. This negative charge will repel to the charge. The charge is entering into the wire. The charge is entering into the wire. Next, this chemical force push this negative charge this direction. This is a chemical force. Chemical force between the this is a repulsion force between the two charges. This is entering into this wire. This is entering into this wire. Similarly, this one. Now, okay, this is a chemical force. Pull the negative charges and keep here. These negative charges are entering the wire. The electrons are moving this direction. Again, these electrons entering here and electric force decreases. Chemical force decreases. The chemical force pushes the electrons in this direction. Again, the electron will enter into the wire. Electrons are moving this direction. This moving this direction. Okay. Battery is connected to the wire is connected to the battery. Wire is connected to the battery. The battery discharges. The battery is discharging. What's the process? Here in this wire, electric force acting on the electrons. Electric force is acting on the electrons. The electrons are moving from low potential to high potential. Here, chemical force is acting. Chemical force is acting on the negative charges. But negative charges are moving from high potential to lower potential. High potential to lower potential. Here, electric force is acting on the electrons. The electrons are moving from lower potential to higher potential. The electrons are moving. Okay. This is the battery working slide. Outside of the battery. Outside of battery. Electric force acting on electrons in wire. Electric force acting on electrons in a wire. Electrons move from this is A point, this is A point, this is a B point, B point, A point, B point. Electrons are moving. Fe acting on the electrons in a wire. Electrons move from A to B, inside the battery. Inside the battery. Chemical force acting on electrons or ions. Chemical force acting on the electrons. The electrons are moving. Electrons move from B to A. B to Fc is acting on electrons. Electrons move from B to A. B to A. This is how. So this outside of the battery, Ft, electric force acting on the electrons in a wire. Electrons move from B to B. Inside the battery, Fc acting on the electrons. Electrons move from B to A. B to A. That is the problem. Okay. Next. Next, electromotive force. Electromotive force. Motive force. EMF. Electromotive force. This is a battery. Say, wire. This is a wire. This is the electrode. This is another electrode. This is a positive. This is a negative. 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 Okay. So what is the electromotive force? Electromotive force. Electromotive force is work done by chemical force acting. Chemical force, chemical force, work done by the chemical force on one unit negative charge, one unit negative charge, negative charge, charge to move it from positive terminal to positive terminal to positive terminal to terminal to negative terminal also terminal to the negative. Work done by the chemical force on one unit negative charge to move it from positive terminal to the negative. Positive terminal to the negative. This is a positive terminal. This is positive terminal. This is a negative terminal. Positive terminal, negative terminal. This positive terminal will act on negative charges. This negative charges. This is a unit Negative charge, negative charge. We know very well this is a electric field setup from this is electric field. Electric field direction of electric field is from positive to negative 10. This is a negative charge. Negative charges are moving from. Negative charges are moved from chemical forces acting. Intensity of electric field is equal to force by charge. F is equal to EQ. But what type of charge? Negative charge. Negative charge. We know very well negative charge, positive. Positive charge moves from higher potential to lower potential. Current is flows from higher potential to lower potential. Electric field is set up from higher potential to lower potential. Drift velocity is set up from higher potential to low potential. Next, electric force, high potential to low potential. Negative charge. Negative charge is moves from low potential to high potential. Next, this is current flows from high potential to low potential. Electric field set up from high potential to low potential. Drift velocity set up from low potential to high potential. Fc is equal to set up from Fc set up from Fc set up from low potential to high potential, right? Potential. This is a chemical force is acting. Chemical force is acting. Chemical force is acting on negative charges. This is chemical. Work done by the chemical force. Chemical force is acting on negative charges. Chemical force is acting on the negative charges. Negative charges are moving from positive terminal to the negative terminal. Positive terminal to the negative. Because this is a work done. Because this is a electromotive force, EMF. This is a EMF. You can write this is for example, in this case, another definition. You can write this is another way also. How can you write the definition? Generally, work done by chemical force on one unit positive charge, positive charge to move it from negative terminal to positive terminal is called as EMF. This is another definition. Both are correct. So both the definitions are correct. You see, in this situation, the battery means this is a battery, this is a wire, this is electrode, this is a negative charge, this is a positive charge. This is a positive or a unit of positive. It is shifting from this direction. This is a chemical force is acting. Chemical force. Chemical force is acting on one unit of positive charge to move from negative terminal to positive terminal. This is a negative terminal. This is a positive terminal. Positive terminal, negative terminal. This is a one unit of positive charge. One unit of positive charge is moving from negative terminal to positive terminal. One unit of negative charge is moving from positive terminal to negative terminal by a chemical force. Chemical force. One unit of negative charges moving from positive terminal to negative terminal by a chemical force. Chemical force. Otherwise, chemical force is acting on the one unit of negative charge moving from positive terminal to negative. Is called as here, chemical force is acting on one unit of positive charge. It's moving from negative terminal to positive. Positive terminal is called as EMF. This is what. This is a very important. This is a very important. Next, next is Ohm's law. Next is Ohm's law. So what is the Ohm's law? Ohm's law. Ohm's law. So what is the Ohm's law? So simply formula is V is equal to IR at constant temperature. Constant temperature. T indicates constant temperature. That's Ohm's law. This is Ohm's law. V is equal to IR formula. So V is equal to IR formula. We are going to write this is a right. This is a V. So V is equal to, we are going to write IR. I is equal to, we are going to write V by R. R is equal to, you can write V by I. It's constant temperature. This is Ohm's law. Okay. In this activity, what we are going to study, what we are going to study. Lab. We are going to explain lab. Lab activity. Lab activity. Lab activity. So what is the lab activity? What is the aim? Aim is to show that to show that the ratio Vy is constant for P for a conductor for a conductor for a for a for a conductor. Ohm's law V is equal to IR at the constant temperature. To show that the ratio V by I is constant for a conductor, constant for a conductor, constant for a conductor. For a conductor. Okay. So what I need is material required. Material required. Material required. Material required. What type of material I want? Materials required. Materials required. So what type of material I want? Manganese wire. One is manganese wire. This is a manganese wire. Next, eliminator of the battery, battery eliminator. This is a battery eliminator. Next, ammeter. Next, voltmeter. Next, rheostat. Next, rheostat. This is a material required. Voltmeter, ammeter. Next, rheostat. Battery eliminator. Switch. This is a open switch. This is a closed switch. Next, conducting wires. This is a conducting wire. This is a connecting wire. This is a material required. This is a device. It is used to measure potential. This is ammeter. It is used to measure current. Voltmeter connects series with the circuit. Ammeter connects parallel. Ammeter connects in a series with a circuit. Voltmeter connects in parallel in a circuit. This is a rheostat. This is a variable resistor. This is a battery eliminator. This is a open switch. This is a closed switch. This is connecting wires. Next, what we have to do means we have to assemble all these parameters. How can we assemble this one? How can we connect this circuit? Now, come to the point. This is a battery eliminator. battery. Positive and negative. This is a magnetic wire. Magnetic wire. Magnetic. This is a voltmeter. This is an ammeter. This is a open space. This is a rheostat. This is a circuit. This is a complete circuit. Complete circuit. Closed switch. Battery emitter. This is an office switch. This is a key. Closed key. Closed key. This is an ammeter. This is an ammeter. This is a magnetic wire. This is a voltmeter. Voltmeter. This is a rheostat. Rheostat. This is a circuit. That is a closed circuit. Okay. This is a closed. What we have to find out means the resistance of magnetic wire. We are finding resistance of magnetic wire. Resistance of magnetic wire in all cases. In all cases, this is what we have to show. Resistance of magnetic wire is constant for different situations. That's what we are going to show in this concept. Our aim is, what is our aim? To show that the ratio V by E is constant. V by E is